Okay, so the topic of today's talk is this symbolic regression using the genetic programming with a chaotic method-based probability mappings. Okay, so it is today's uh, index. First, I'd like to introduce some background for this study. As you know that the genetic programming is one of the evolutionary computing algorithm but it is quite different with another evolutionary algorithm that for for the genetic programming, you, you do not only need to focus on optimize the final result, but also need to optimize the construct for the solution. And here is some feature for the genetic programming. The first, it has no limitation of data sets for solution. That means before we get the final result, we don't know how huge will the result be. We don't know the specific sets for the solution. It could be small, also could be very huge. We don't know that. And the second, does not make a distinction between the searching and the solution spaces. That means we do not have any encode or decode for the genetic programming. Like, for the typical genetic algorithm that you need to transfer the data to the binary number, then decode the binary number back to the data again. But for the GP, we do not have that anymore. And third one is also one most important one is for the genetic programming, all the data, the solution is represented by a very specific hierarchical manner. That means such as basically you can consider it as the linked list based data structure like tree, a graph, stick, something like that. And today we will focus on the tree-based genetic programming. Also, is one of the most typical one. We're using the tree to represent the result. Okay, so it is how does tree-based genetic programming to do the crossover operation. And here is how does the GP do the mutation. Basically, the idea is very simple that first you have a random search to pick a random node, then to generate a new node to replace in the same place. And for the crossover, it's also same. At first, you need to have two times of the random pick to pick two individuals from the total populations, then to have a random search again for each one to pick the nodes. Then you need to pick the position, then cross over the subtree from the selected position, then add, and now we will get the two new individual, right? Then add these two new individuals to the new generation. So it is the problem we are solving with genetic programming for this study. It's called a symbolic regression. Basically, that means we are going to search a specific mathematical formula that able to fit the given data set. And as the title said, we also use some, the chaos theory for this study. And the logistic mapping is one of the most classical simple and classical chaos system. And for the chaos system, they had following features. First, the sensitive. the cast mapping is very sensitive with the input data, and second, the randomness. It's very hard to predict the number for the cast mapping, and third one is ergodicity. It's that means the number we get from the cal system, they are not be repeated. Okay, so here is the next I'd like to introduce my motivation for this study. Basically, it is a simple idea that first, you know that when we from a lot of experiments, we find that there have okay. So before that, I got to introduce how does genetic programming to generate a new tree. Okay, to generate a new individual. First, we have a root node. Then first we're going to generate a new node. Then have a random pick, have a selection. Decide it is a operation node or it is a terminal node. Then if it is a terminal node, we will have a randomly search, randomly selection from the defaulted operator to decide which operator it will be. Or if it is a terminal node, we will have a randomly pick also to decide which value it will be. And from the experiments, we discover that for some data set, it is very obviously that some operator is not suitable for some data sets. So our idea is to find a specific probability mapping for each operator that by the pre-learning before we go into the conventional genetic programming. Yeah, and here is our proposed method. So here is a flowchart for this method. And next, I'd like to introduce some experiments for our study. For now, we designed 3 stages for this experiments for this study. Part 1, we did a competition between the conventional genetic programming and the new method. And the part 2, we're discussing the influence of the different random number generators. The part 3, we're discussing the different pre-learning method and limited total competition. Okay, so it is a the data set we used for this experiments, which called yacht hydrodynamic data set. It has totally 7 attributions. That means 6 features and 1 label. So it is a 6-dimensional data for the regression program. It is a parameter we used with setting for the genetic programming, and let's focus on the operator set. We have plus, minus, multiply, divide, and so on, totally 9 operators, and x0 to the x5, totally 6 terminal sets. And we're using the tournament selection as to select the better individual. Okay, so it is a result for the first stage. First, we focus on the result between the conventional genetic programming and this random search proposed method A. This RS means a random search. Okay, so we can see that the proposed method A got better results than the conventional genetic programming. Conventional genetic programming, and then the difference between the A and B is B got more competition at the pre-learning stage. So, and the B got a little bit better result than the A. So we can thinking that at least for this data set, the proposed method, it works. We can obtain a better result by this new method, and but B better than A means if we give the more competition to the pre-learning, we can get a better result. And it is a Wilcoxon signed rank test, which is a significant difference test. In principle, we think if this number smaller than the 0.05, we consider this true sort of data has a significant difference. And let's check out the data that the conventional genetic programming with proposed method A has a significant difference, and the B with conventional genetic programming also got the significant difference, but the A with the B does not have a significant difference, because as I said, the difference between the A and B is just the B got more completion at the pre-learning part. And it is the result for the stage 2. Okay, so for the stage 2, we did a competition between we used another, the chaotic mapping as a random number generator. We used the logistic mapping, sign mapping, and the tint mapping for this experiment. And we can see that the logistic mapping and sign mapping got very similar distribution, with that it has a higher probability to get results from the 0 to 0.1 and the 0.9 to 1. But for the tint mapping, we cannot see any feature from this distribution. It looks very random, right? And so that we consider that, because we want to know, is that the distribution affects the final result, or because the feature of the chaos affect the final result. So we designed a function which called pseudo-random, which that had a very similar distribution with a logistic mapping and sign mapping, but it is not a chaotic mapping. So here is the results that we can see that the tint, the logistic mapping, pseudo-random, and the sign mapping, all of these three mapping got better results than the tint mapping and random mapping. So we think but it does not have a very significant difference between the pseudo-random and with the logistic mapping and the sign mapping. So we consider that maybe it is the reason, maybe the distribution affects the final results, but rather than the the feature of the chaotic. Okay, so for the stage 3, it is a parameter we're setting for stage 3. For stage 3, the purpose for the experiment 3 is going to talk about the computation. We control the total computation for this 3 method. You can see that it is 10,000. That means we make all of these 3 methods only has a 10,000 times chance to evaluate the uh, fitness. And this RS means random based. This GA means the genetic algorithm based, because as I said, this pre-learning is quite like another NP optimized problem. So we can use another, the algorithmic algorithm to solve this problem. We can use another optimization algorithm to solve this problem. So far we deployed a random search based and genetic algorithm based. So here is a result. Okay, so we can see that actually we cannot get the conventional genetic programming gets a better result than the rest of 2 algorithm. So because obviously that we do not have enough competition for this pre-learning phase. If we give the more competition, if we give the more resource for the pre-learning part, we believe that the proposed method going to have better results than the conventional genetic programming. So we can after from the experiments that we can see that our proposed method is more suitable for the stage which has a satisfied computing resource. So in the conclusion, let me do the for the experiment 1. We can see that a good probability mapping for each operator do improve the performance of the genetic programming. And second, for the second experiment, we can see that the logistic mapping can obtain better results because it's specific distribution. And in the last experiment, we think the proposed method is more suited for the case that has enough computing resources. Okay, so in future study, because so far for this pre-learning method, there has quite a large hyperparameter for this pre-learning, and those hyperparameter is setting by the human experience, so that we would like to use some way to find a self-adapt way to solve this hyperparameter. We want to make it automatically self-adapt. And the second, we are going to trying to combine the proposed problem pre-learning to the genetic programming process, because have a extra pre-learning going to waste a lot of computing resource. Okay, basically that's all. Thanks for your listening.